This is a demo on the workings of APRS in my area. I live on the east coast of Australia in Newcastle, just north of Newcastle. And here I'm just showing you how APRS.fi, which is a website that collates all the traffic, shows how, in this case, a truck driving north is being heard by various digipeaters and eye gates that then relate the information back into the internet. And you can see how the vehicle is sometimes going to a digi direct and sometimes to an eye gate direct. There's a few stations. There's this car that was driving around. Seems to be stationary at the moment. And it first gets heard then by Mount Sugarloaf. And then Mount Sugarloaf doesn't have the internet connection, so it then repeats the packet. And when an eye gate then hears it, it will insert that into the internet. This station looks like a red D, but it's actually hidden behind it is the eye gate. It's a receive only. Here's a list of all the raw packets that it receives and the stations that it hears. This is straight from APRS.fi, and it gives you an idea of what the actual format is of the packets as they are being received, plus actually quite a bit of extra information. Here's my station. I'm currently running a TNC Pi, which sits on top of a Raspberry Pi. And I've written a little web interface, which I called ACP, APRS Control Panel, or Configuration Panel. And that makes it a bit easier to control the unit, set it up for different digipeating situations or change a call sign. Just going through some of the information here from the other stations that we're driving around. And in particular the truck VK2 LPC-9 is still traveling north at this stage, and I just want to show you how it actually appears on both APRS as well as on the eye gates, so you have an idea of what sort of information is being sent and received and how it appears when things are running as per normal. The nice thing about APRS.fi is that it sort of extrapolates the speed at which something is moving, and you can see in a blue line in front of the truck in this case that the predicted position is shown on the map by a little blue line that, based on the past speed and direction, will show you where it's likely to appear next. Obviously it's following the road, but it gives you an idea as to where it most likely is. The tracker in the truck does not always send a packet at every turn. Sometimes there's other things involved, like how long has it been since I last sent a packet, or did I make a turn in the road more than so many degrees, or is my speed above or below a certain point. That can influence how often something is transmitting. So here's an overview of the home page of the APRS configuration panel that I wrote. It gives you a bit of information as to the station that you're running, how it's presenting itself on the network, your call sign, how many received packets or how many sent packets. The last 10 raw packets appear on the screen. That's just live. As soon as they are heard, the screen gets updated. And there's a graph showing you over time how busy the system has been. The green bits is the number of bits per second, and the black line is how many packets per hour. And you can see that it sort of goes up and down depending on time of day. But right now we're getting about over 100 packets per hour. And it's a fairly quiet location here, APRS wise. There's not too much happening. Here you can see a few packets just got updated. And it'd be interesting to see when the truck will send out another packet. See, at this stage you don't know if this truck is has stopped, maybe pulled over and went out for a bite to eat. I know that where it is right now, the last known position is not near shops. It's just a bit of highway there, so it should move on. But obviously it hasn't triggered anything yet based on speed or turn number of degrees or anything else that makes it want to retransmit. It can take quite a couple of minutes before you see another packet, and that's just fine. That's just how the system works. It's all based on not overloading the system. And you can see in the meantime there's all sorts of other packages coming through. VK2 UNI, VK2 EVB, and we'll just keep an eye on the truck here, LPC, when it appears next. The ACP that I wrote is all web-based. If you want to change your call sign or your location, you should only have to log into this site and update some parameters, and you're good to go again. As said, it runs on a Raspberry Pi. It's quite a low cost and fairly robust solution to set up an APRS station for yourself. If you have trouble getting one of those TNC Pis, because the manufacturer Coastal Chipworks has ceased trading, then you can change the system so that it uses a USB-based SDR like the RTL SDR. So here I'm going to show a few things on the GUI and the types of information that you can access. You can configure APRX, which is the core encoding and decoding APRS software that I use. You can start the service, stop the service, a bit of system information. Time synchronization. I've made it so that it is possible to also update the system if there's a good enough version available, or if there's an update available that really enhances features or fixes some bugs. I've put all sorts of documentation on here as well, so giving you a better idea of what it's all about. But this is a bit of history as to why I wrote it and how it works. The setup on the bench here, and that's pretty much what it looks like. So let's just continue following this truck, and looks like it hasn't sent any packages yet. No, that's all fine. So even there's curves in the road, and it's been a while since it's last sent out this packet. It probably doesn't believe it's necessary to send out another packet. That's the sign of a fairly intelligent tracker, the little device that sends out the packet. I say little device, it could be built into a ham radio as well, a radio that supports APRS. And there's the packet, LPC. So that means it's now updated on the map. And when we zoom in, we can then see, based on its past speed and direction, where it's likely to be next.